Okay, welcome back and welcome to lesson 6 of module 2. We're just going to pick up where we left off, which was when we were first getting into our work with rotations. Today we're going to learn a couple rules for them and get some good practice in. So let's move on and go over our objective for today. All right, today's objective is that by the end of the lesson you'll be able to perform rotations on a coordinate grid. You'll know you're successful when you can prove that a rotation of 180 degrees moves a point on the coordinate plane from A, B to negative A, negative B. So basically just makes the points the opposite. Okay, let's go ahead and get started. All right, starting off with example 1. This is just kind of building some background with you. It says the picture below shows what happens when there's a rotation of 180 degrees. So this is key. This is how much we're rotating today around center O. Okay, so if you really think about 180 degrees, that is half of 360. Okay, and so instead of doing a full circle around, a full rotation, it's halfway. Okay, halfway around a circle. It kind of forms a semicircle. It says that the center is O, and so we're rotating these points around that center. So here's the points we're rotating. We're rotating point P around that center O, and we are rotating point Q around that center O. So you'll see when P is rotated, it goes halfway around, and here's P prime. This is it after it's been rotated. And when Q is rotated, you'll see it goes halfway around, and here's Q prime. Okay? And what you should notice here is obviously that half circle, it lines those points up. So they actually form a line with their other point because you know that 180 degrees is a straight line. So it forms a line with the points after they have been rotated. Okay? So that's the first thing I want you to notice is that if we rotate something 180 degrees, it's going to line up and create a straight line with its new prime point. All right? And that is only if we're rotating 180 degrees. Let's continue on. All right, the next thing I want to show you is this is pretty much the same thing. It's just done on a coordinate grid. So we're going to be working with coordinate grids today. We're still rotating 180 degrees. I'm sorry about this Google Drive thing. I don't know what that is or how that got there. And we're still rotating around center O. So here's center O. And we're going to be rotating point P and point A. So you'll notice point P is rotated around 180 degrees and it forms a straight line. And here's P prime. And same with A. It's rotated 180 degrees and it forms A prime. Now the one thing I want us to notice now is that we have a coordinate grid. We can write down exactly the location of these points. So starting with point P, this is at negative 1, 2, 3, 4. Negative 4. Up 1, 2, 3. Positive 3. Okay? And if we look at P prime, this point is at positive 1, 2, 3, 4. This is P prime. So positive 4 down, so negative 1, 2, 3. Okay, let's do point A and A prime, A and A prime, and look at their coordinate locations too and see if we can find a pattern. So A is at over negative 1, 2, 3, 4, up 0. So back 4, up 0. A prime is at positive 1, 2, 3, 4, up 0. So positive 4, 0. So if we look at these points, what I want you to notice is the pattern. So we started with a negative 4, it became a positive 4. Started with a positive 3, it became a negative 3. So they're opposite. So when you rotate something 180 degrees, the points basically become opposites. You just change the signs. Okay? So we did the same thing for our point A. Started with negative 4, 0. It became positive 4, 0. Now 0 doesn't change because 0 isn't positive or negative. So that's the one case where nothing's going to happen to that 0. But you can see that our points are opposite. So the rule, and I want to write it down so that you have it. So please write this down as well. The rule, if you rotate something 180 degrees, then the points go from what they originally were to just be opposite of what they originally were. Okay? And if you start with a negative, then it'll be a positive. If you start with a positive, it'll be a negative. Basically, you just change the sign. Okay? The other thing is from our previous slide as well. Remember that they do form a line, so they're collinear. So P forms a line with P prime, A forms a line with A prime. Okay, moving on. All right, just to go over what we've learned so far is that when you do 180 degrees, it is collinear. So if you rotate point P 180 degrees, it's going to form a line with P prime. Basically, that's what collinear means, right? They lie on the same line. Also, when you do a 180 degree rotation around the origin, it has to be around the origin, then the rule is if you start off with positive numbers, they become negative. If you start off with negative numbers, they become positive. Basically, your points are just going to be the opposite sign from the original to the prime. So, for example, if I have negative 5, 2 as my original and I do a 180 degree rotation, it would become positive 5, negative 2. If I have 0, 4 and I do a 180 degree rotation, 0 doesn't have a sign, so it stays the same, and this would become a negative 4. If I have 3, 6, I'm going to do a 180 degree rotation, this becomes negative 3, negative 6. You just do the opposite of whatever it was that it started with. Okay, let's continue on. All right, it says using your transparency, we don't have transparency, so we're not going to do that. Rotate the plane 180 degrees around the origin. So we are rotating around the origin, so our rules do apply. What are the coordinates of the rotation of this point? 2, negative 4. So we're starting here at 2, negative 4. If we were doing 180 degrees around the origin right here, then our new point, based on that rule we just talked about, is going to be the opposite of 2, which is negative 2, the opposite of negative 4, which is positive 4. So this is where it's going to be negative 2, 1, 2, positive 4, 1, 2, 3, 4. Okay, and those are going to form a line. They're going to be collinear, and we'll just mark where this point is. This is at negative 2, positive 4. Okay, that's our answer here. Pretty simple stuff. Let's move on to the next exercise. All right, I want you to go ahead and do the same thing here. This is the point they give you, and then just show me where it would be if you were to rotate this 180 degrees around this origin. Okay, give you a second to do that before I reveal the answer. All right, if our original point was negative 3, positive 5, our new point is going to be positive 3, the opposite of negative 3. So positive 1, 2, 3. And instead of positive 5, it's going to be negative 5. Negative 1, 2, 3, 4, 5. So this is going to be the new point. And again, this is at positive 3, negative 5. And you'll see that these are collinear. Okay. So that is our answer here. That's where the new point would be if we did a 180 degree rotation. Let's move on to the next exercise. All right, this time we are rotating this entire line around the origin, still 180 degrees, and we're doing this line. So when you have a line, you just need to identify 2 points, or in this case, they give you one of the points. But you just need to identify another point so that you can basically rotate that point. So if this is one of the points that they're starting with, negative 6, positive 6, which is right here, then I know that the rotated line is going to be a positive 6, negative 6. So it would be positive 6, negative 6 right here. And because this is a straight horizontal line, I know the new line is just going to be right here. Okay, if it wasn't straight, I would just need another point so that I could connect them. All right, so that is this line, this whole line rotated around the center of the coordinate grid, 180 degrees. And you'll see that they are collinear still. They form a straight line when you connect them. And we would call this line L prime. Okay, make sure you have it down, and then we'll continue on. All right, go ahead and try this one out on your own. You're going to rotate this whole line 180 degrees. This is one of the points on this line, 7, 0. So where would the opposite of this line be after we rotated 180 degrees? All right, based on the rule, our first point, 7, is going to become a negative 7, and our 0 is going to stay a 0 because that doesn't have a positive or negative sign. So this is going to be negative 7, 0. So this is where the new point is. And again, it is this time it's vertical. We did a full 180-degree turn, and you'll see that it is collinear. They still do line up when you go through the axis. Okay, now we're going to get into some diagonals. All right, go ahead and rotate this one. I thought we were doing diagonals, but we're not yet. So go ahead and look at the point they give you and rotate it. All right, they give us 0.02. So the opposite of that is 0, -2. The new line would be right down here. You'll notice that the points are collinear. Okay, and they're also parallel. Our lines are parallel to one another. Okay, make sure you have that down, and let's move on. Same thing again. Look at the point they give you, 4, 0. Is this line a 180-degree rotation of this line? Well, it is, because this one is at 4, 0. This one is at -4, 0. And they're collinear. They form a straight line. So we know this has been rotated 180 degrees. And they're parallel. All right, moving on. Okay, this is the last one like this, but it says, let line L be a line passing through 0, -1. So it's right here, 0, -1. What would be the rotation of this? Very quickly, you should be able to say, oh, it's 0, +1. So it's going to be right here. You should be able to identify that line, and you should be able to see that those two lines are parallel. L and L prime are parallel lines, and they are collinear. The points that are on them are collinear. Okay, let's now get into some diagonal lines. All right, when we work with a diagonal line, basically, if we wanted to rotate this diagonal line, we need to find 2 points on this line. So I see one right here and one right here. You only need 2 points because it just takes 2 points to form a line. On the ones before this example or exercise, we didn't need 2 points because they were straight lines. But this one's diagonal, so we need to know exactly the angle of the slope. So this first one is over 1, 2, 3, 4, up 1, 2, 3. So this one is at 4, 3. And this second point down here is at over 1, 2, 3, 3. 1, 2, 3, down 1, 2. 3, -2. So really quickly, you should be able to identify exactly where these new points would be if they were rotated 180 degrees. This one is going to be -4, -3. So -1, 2, 3, 4, -1, 2, 3. And then this second one is going to be -3, +2. -1, 2, 3, +1, 2. Okay. So this has been rotated 180 degrees. This is the line that it forms. We can make it straight. A little curvy, but it's okay. And this would be line L prime. It has been rotated around this origin. Do our lines form collinear points? Or do our points form collinear lines? Yes, 3, -2 and -3, +2. They're collinear. And these other 2 points are also collinear. All right, that's the rotation. So again, just choose 2 points and then apply our rule for 180-degree rotations. Here is our lesson summary today. Anytime we rotate something 180 degrees around the origin, basically the line, the first point, and then the image of that first point, the line is collinear. So they lie on the same line. Second thing is that when we have a 180-degree rotation around the origin, our rule is that our points just get changed to be the opposite of what they originally were. Okay? You are now going to move on to your exit ticket in Galileo and your reflection in Google Classroom. Keep in mind you have Movie Max this week and you have an extra credit assignment should you wish to do it. It's optional for Prodigy.